Okay, this week we are going to talk about analysis of covariance, or it's oftentimes called Ancova. And this is going to be our last extension of an Ancova for the course. So what is an Ancova? All right, again, it's an extension of a one-way ANOVA that incorporates a covariate variable. It's important that this covariate is linearly related to the dependent variable, and we're going to talk about some examples. The inclusion of the covariate increases the ability to detect differences between groups of an independent variable. So you don't add this covariate out of, say, curiosity, but it's usually because there's this known linear relationship between the covariate and the dependent variable. And you think by including this in the model, you're going to increase your power or ability to detect differences between the groups of the independent variable and the dependent variable. Ancova is used to determine whether there are significant differences between the adjusted, and that's what makes this important and different, is between the adjusted population means of two or more independent groups. All right, so what would be an example? All right, we could use an Ancova to determine whether math exam performance differed based on math efficacy levels among students while controlling for math utility. All right, so what does all this mean? All right, your dependent variable would be exam performance, and this is a continuous variable measured 0 to 100. Your independent variable would be math efficacy level. And in this situation, we've created 3 groups for students based on their efficacy. We have a low efficacy group, a moderate efficacy group, and a high efficacy group. And then we want to control for math utility, or how useful they think math is, because we believe that the effect of math efficacy on exam performance will depend to some degree on the student's math utility. And here, math utility is a continuous variable. All right, so what are some study designs which would warrant an Ancova? All right, one example would be analyzing pre-post study designs. All right, so what do we mean? If you have a study design that measures the same dependent variable in 2 or more independent groups over 2 time points. Right, so what would be an example? You might want to determine any changes in motor skills before and after 3 different types of motor skill intervention. So maybe we have an expert-led group, we have a teacher-led group, and then we have a control group. All right, and as you believe the post-intervention scores will depend to some degree on the pre-intervention scores, you compare differences in post-intervention scores between the interventions with the pre-intervention scores as a covariate. And I know this sounds really complicated, and you may even be asking, well, didn't we just do this last week with the mixed ANOVA? And the answer is to some degree, yes. With the mixed ANOVA, we had the pre-intervention and the post-intervention scores as a within factor for these children. But in this situation, our dependent variable is only the post-intervention scores, and we're treating the pre-intervention scores as a covariate. All right, another example would be reducing the effect of an extraneous variable. So if you have a study design where you are measuring a dependent variable in 2 or more independent groups and want to control for the effect of another variable known or thought to influence the dependent variable. So an example here would be if you wish to compare the differences in physical activity for different levels of visual impairment. You might use body mass as a covariate, as this may also have an effect on physical activity levels. Okay, what are the assumptions that we need in place to be able to run an Ancova? All right, well, as usual in the ANOVA world, we need one continuous dependent variable. We need one independent variable that consists of 2 or more categorical independent groups. Examples would be race, ethnicity, college major as here I've given you 3 groups: traditional STEM, non-STEM, and health sciences. Another example would be physical activity level, where we have 4 groups: sedentary, low, moderate, and high. We also need a continuous covariate variable. And please pay attention here to the most important part here with the covariate is that it does need to be continuous. A lot of times we do think about controlling for things like gender or race, ethnicity, but in an Ancova, we need that covariate to be continuous. And it's used to adjust the means of the groups of the categorical independent variable, very similar to what we saw in multiple regression. You can have more than one continuous covariate, but in this class, we're just going to focus on one. And if your covariate is categorical, then the analysis is not always called an Ancova. All right. Per usual, we need independence of observations. So no relationship between the observations in each group of the independent variable. As I previously mentioned, the covariate is linearly related to the dependent variable at each level of the independent variable. We need something called homogeneity of regression lines, and I'll explain a little bit more about that. So the regression lines for each of the independent groups are parallel to each other. All right, so here's an example where the assumption is met. So we see exam score, math utility on our horizontal axis, which is our covariate, and we see lines for our 3 groups of efficacy, and notice all 3 lines are parallel. So this would represent homogeneity of regression lines. So what happens if the assumption is violated? In this picture, we see that the 3 lines for high, moderate, and low efficacy are not parallel. They're actually skewed and would eventually intersect if left to continue. And so in this situation, we do not have homogeneity of regression lines. All right, continuing with our assumptions, the dependent variable is normally distributed for each group of the independent variable. We have homoscedasticity of residuals or equal error variances. And we also have homogeneity of variances. The variance of the residuals is equal for all groups of the independent variable. And some of these we've seen before, but we'll go through them again once we get into our JASP example. And then lastly, there are no significant outliers. Okay, 10 assumptions that have to be met for us to be able to run an Ancova. All right, what is our working example here? We wish to explore the relationship between home literary resources and 9th grade reading achievement. However, we wish to control for the student's extrinsic motivation. Extrinsic motivation is the motivation to perform well academically in order to satisfy external goals like future job opportunities or financial security. And you'll see where sometimes I refer to it as extrinsic motivation and sometimes I refer to it as instrumental motivation. In this particular data set, the educational longitudinal study, it was referred to as instrumental motivation. But if you've taken our motivation course, EDPY 785, then you've heard it referred to as extrinsic motivation. All right, so what are home literary resources? So our independent categorical variable, the options for home literary resources, and keep in mind this was in 2002, so it does appear a little bit dated at this point. Our options were 50 books, a daily newspaper, and a regularly received magazine. And so students answered 0 for none of the resources, 1 for one of those resources available, 2 for 2 available, and then lastly, they would answer 3 if all of those resources were available to them in the home. All right, so the first thing we want to do is run our descriptive statistics. And so here we're looking for normality of standardized ninth grade reading achievement in our 4 groups for home literary resources. And when we look at the p-value of the Shapiro-Wilk test, we actually notice that they're all significant. So notice here that we've got p-values less than 0.05 for 0, 1, and 2 resources, and 3 was unable to calculate because the sample size is too large in that group. So it's looking like we probably don't have our normality assumption met, but for the sake of this example, I'm going to continue forward. All right, let's go to our box plots in JASP and take a look at and see if we have any outliers. And we notice for 0, 1, and 2 resources, let's see, for 0 and 1 resources, we've got a few high outliers. And then for 2 resources in the home, we have a couple of high outliers, and we have what looks like 6 outliers down low. All right, so there are a few outliers, but keep in mind this data set is extremely large. This data set has 15,892 students in it. And so with the few outliers that we see, we're not overly concerned. All right, let's go into Ancova. So if you'll click on Ancova in JASP and select Ancova, we'll see the box here pop up for us. And what we want to do is put standardized reading achievement for base year or 9th grade in our dependent variable. So that's BYTX RSTD goes in our dependent variable. Our fixed factor is base year home lit or the home literary resources. And then our continuous covariate is the base year instrumental or extrinsic motivation. Just as we've been doing, we're going to check descriptive statistics, estimates of effect size, and we want omega squared. And under assumption checks, we want homogeneity tests and the QQ plot of residuals. Also, if you'll scroll down to marginal means, we want to move base year home literary resources over into our box for calculating marginal means. Okay, so let's work on understanding the output that you see. First, let's start with our assumption checks. And we see with Levine's test for equality of variances that our p-value is greater than 0.05. And so the assumption of homogeneity of variances is met for this example. All right, we can then look at our QQ plot, and we see by and large that the QQ plot appears to be normal. We see a little bit of deviation there at the 2 ends, but by and large this is represents a normal distribution, and so we can assume homoscedasticity in this situation. All right, so let's turn to the output now, and I've just as a reminder, I've put interpreting effect sizes in the top right-hand corner of this slide, and again, we're going to be interpreting omega squared. All right, so here is our Ancova table, and let's look at our p-value for home literary resources, and we see a p-value of less than 0.001, so it is significant. So the effects of home literary resources on reading achievement are significant when adjusted for the effects of instrumental motivation. All right, and if we look at instrumental motivation, we see another significant p-value, and so the covariate instrumental or extrinsic motivation significantly predicts reading achievement. All right, so why did I ask you to calculate the marginal means? Because I want you to understand that the means for reading achievement across the home literary groups is adjusted for the extrinsic motivation. So you have your descriptives table in JASP, and with this descriptives table, it shows the unadjusted means for reading achievement for the 4 categories of home literary resources. But then with marginal means, this shows the adjusted means for reading achievement when considering for the effects of instrumental motivation. So notice, let's just take, for example, no literary resources in the home, and we see an unadjusted mean of 44.787. But if we look over at our marginal means, once we've adjusted for our extrinsic motivation, we see that marginal mean is actually a little bit higher. It's 45.184. All right, so we want to test for our Ancova assumptions. I'm jumping a little bit around assumptions. And here we want to try to test for that homogeneity of regression. Remember, this was when we saw the math efficacy groups, those lines were parallel. All right, so how do we check this? All right, so go back to your input side on the left, and under model, highlight home literary resources and instrumental motivation. So select them both and move them over into model terms. And this creates an interaction term of home literary resources and instrumental motivation. All right, and now we see in our output in our Ancova table that we have that interaction term included. And what we're looking at is the p-value. We want that p-value to not be significant, because if there is no interaction, then we can make the assumption that we have those parallel lines across groups or homogeneity of regression. So here we see a p-value of 0.12. So the interaction is not significant. The relationships between instrumental motivation and reading achievement are the same in each literary resource group. If this is significant, then there'll be concerns over the validity of the Ancova analysis. All right, now if you are following along in JAS, before we move forward, you may want to pause the video. Make sure you remove the interaction term from that model box before moving forward. All right, so the last thing we want to do here is our post hoc testing. We did have a significant p-value for the home literary resources. So in our input, we want to look under post hoc tests, and we want to add the base year home literary resources. We want to check effect size. We want to choose the Bonferroni correction, as we've always done, and we want to flag significant comparisons. So now we can take a look at our post hoc test results. And for all of these pairwise comparisons, we see a significant p-value of less than 0.001. So these significant differences, again, are between each pairwise comparison. And we can see that reading achievement is higher when the student has access to more home resources. And so we see that as the number of home resources goes up, then the standardized reading achievement becomes significantly higher from the lower group. Okay, we have finally made it to reporting the results in APA format. So there's a lot here we need to report, so let's just take this slowly. An Ancova was run to determine the relationship between home literary resources and 9th grade reading achievement, controlling for student extrinsic motivation. All right, there was homogeneity of regression slopes as the interaction term was not statistically significant. And here we report our F-test with our numerator and denominator or residual degrees of freedom. We report the value of the F-test, 1.944, and we report our p-value of 0.120. There was homoscedasticity and homogeneity of variances as assessed by visual inspection of a QQ plot and Levine's test of homogeneity of variance, and we report that p-value of 0.248 respectively. There were a few outliers in the data set, but again, this data set's very large, and so we were not worried about these few outliers. After adjustment for extrinsic motivation, there was a statistically significant difference in 9th grade reading achievement between the home literary groups. And again, we report our F test. So we report our 3 degrees of freedom for the home literary group, and we report the degrees of freedom for our residuals, 10,439. We report the value of the F test, 176.096. We report the p-value of less than 0.001, and we report our effect size omega squared of 0.047, and we note that this shows a small to medium effect. Post hoc analysis was performed with a Bonferroni adjustment. Students with all 3 resource options had statistically significantly higher reading achievement compared to students with 2 resources, and we report that mean difference of negative 1.71, the standard error of 0.214, and the significant p-value of less than 0.001. We do the same for the comparison with 1 resource and the comparison with no resources in the home. We then go to students with 2 resource options in the home and note they had statistically significantly higher reading achievement compared to students with 1 resource in the home. And again, we report that mean difference, the standard error, and the p-value. And students with no resources in the home, again, reporting the mean difference, the standard error, and the p-value. Lastly, students with 1 resource option had statistically significantly higher reading achievement compared to students with no resources, and we report that mean difference, the standard error, and the significant p-value. All right, at this point, I believe you are ready for the classwork.